In the previous video, we got to learn about the simplest neural network, or the perceptron. However, a perceptron is still a linear decision rule, so it doesn't have this power that we need to classify non-linearly separable data on its own. One approach that we can use is to connect multiple perceptrons together in order to form a larger network. So here in this example we have a multi-layered neural network, or a multi-layered perceptron, in which we have connected multiple perceptrons together. So if we take a look at this here are the inputs, and along with this output, this represents one one perceptron. Then we can look at, again, the same inputs along with this output represents a second perceptron. If we look at, again, the same inputs and this output, then we get a third perceptron. So again, we can see here we've connected the three perceptrons together, and then again these perceptrons, so these outputs here, are additionally connected to this output here. So now we have not only have we connected these three perceptrons here, but we then use these the outputs of these three perceptrons as inputs to the second as inputs in the second perceptron. So in way this so this connects so this is a network. So here we can see an example of multiple layers. So the first layer is here, the inputs. Then we have this hidden layer here where we get the outputs, so these first outputs of this first perceptrons. And then again we have this output layer here in which we get the output of the this perceptron here. However, this still is only a linear decision rule, because we're only connecting linear functions with each other. That is, when we compute this output here or here or here, we still only compute, we still only use a linear function, and we use a linear function again here. This won't help us if we want to use if we want to classify more complex data. This will still this can collapse into one linear decision rule. So in order to do this, we can this is what we said here. If we use a linear activation function in this case, then the neural network is still just pretty much equivalent to having one layer, only with different weights. So modern neural network models use nonlinear activation functions. So instead of using this linear activation function that we said, if the input is below a certain value, we output 1. If the value that we get is below some certain value, is below that same value, then we output -1. Instead of using that, we can use nonlinear activation functions. For example, we could input this, so this sum that we get when we multiply each input by the weight with which it's connected to a given neuron, and we pass it to a sigmoid activation function. We'll see what a sigmoid activation function is. If we construct the model in this way, then it can be used to create complex mappings between the network's inputs and outputs. So then it can be used to a model and classify more complex data. Some examples in which these neural networks can be used and are especially useful for classifying in areas where other models aren't as successful include images, video, and audio, as well as datasets with high dimensionality. We often have this in ambient assisted living, since we need to analyze people's movements that can be so we can get the data in the form of video or images, or in some of the other courses we saw some datasets with high dimensionality, which can also be better served if we classify them using neural networks. So let's see what a multilayer perceptron looks like more generally. So a multilayer perceptron is a neural network which is composed of multiple perceptrons, as we saw, organized in more than one layer. So at the very least we need to have one input layer, then one hidden layer. So each neuron in the input layer is connected to one neuron in the hidden layer. So in the hidden layer we compute some outputs based on the values that come from the inputs multiplied by the weights with which each neuron is connected to the neuron in the hidden layer. We compute some outputs and then we pass them on again to the next layer. In the example here we have one output layer. So again the connection between the hidden layer and the output layer is done the same way as the connection between the input layer and the hidden layer. Each neuron here is connected to so each neuron here is connected to one output layer, and each output layer is connected to all neurons in the hidden layer. And at the very least, if we want to have a multi-layer network, we want to have an input layer, one hidden layer, and one output layer. But we can also have multiple hidden layers between the input and the output layers, so it doesn't just have to be one. There are activation functions, so the function that we use to compute this signal that we pass on to the next layer doesn't have to be the threshold function that we used in the perceptron example. Instead of this, we can use other functions, which we'll see in a future video.